Alright, here is my video on how to reduce complex fractions. We're going to work on writing the steps down, which are right here, as we go. So first I want to show you the procedure. As you can see, the first step is already done because I made a mistake and I had to start over. So the first step is make each part a fraction. So if it's not a fraction, put it over 1, make it a fraction. Then with subtraction, keep change, change. This just ensures that you don't lose that negative while you're doing this. Then you make each part have the same denominator. So we have 4 fractions here. 1, 2, 3, 4. And we need to have a common denominator for all 4. So all of them, we only have b and we have 1. So this should be a very simple one. b is our common denominator. I like to write it up here just so that we know. So to make this one have b as a denominator, we multiply it times b over b. Same deal with this one. This one is already has b as a denominator, and so does that one. Once we do that, we rewrite this fraction as 2 fractions over each other. So b is in the denominator here, and a minus b, because we did this multiplication here to get the negative b, is there. This one down here, we have a b in this denominator, and it's a plus b. Okay, when the denominators are the same, we simply can eliminate the denominator. And this is because we can keep this one the same, change this to multiplication, and flip. So I'll do it once so you can see this one, but I won't ever do this again. We can just cross out the denominator. So it's a minus b over b, that's your keep. This is a division sign, so we'll just change that to multiplication, and then flip this fraction. Okay, doing that, these guys cancel out, and we're just left with a minus b over a plus b. Now, the same thing would have happened if we just crossed those out. So we can do this because of this. There's your final answer. If you can, you factor and try to reduce, but in this case, you didn't have to. Okay, so the basic steps, hopefully I can make it all fit, is make all parts fractions, keep change, change if you have to, find a least common denominator, LCD, or just a common denominator. It really doesn't matter if it's least. Step 4, make all of the fractions have the same least common denominator. It got cut off. And keep change flip, which is the same thing as just eliminate the like denominators, and reduce the resulting simple fraction. And we put simple in fraction in quotes because it's really not simple, but it's a lot simpler than the complex one we started with. So if you need to copy these notes down, please just pause your video, and we're going to move on to the next example. Okay, this one here, very similar to the other one. If you want to try this one on your own, please feel free. Pause it and try it. Otherwise, I'm going to do it right here, following each of the steps. Make each part a fraction. Keep change, change where necessary. Make each one have the same common denominator. That means all 4 have to have the same common denominator. So since x is here and 1 is there, the obvious answer, hopefully you can see that, is x. So I have to make, this one has an x, I have got to get this one to have an x, so I multiply the top and the bottom of that little fraction by x, and same for this one. Okay, now I can write this top one as 1 fraction. The x is the denominator, 4 doesn't change. I multiply the negative 2 times the x, And I get that for the top. Down here, x's again. Here, 6 times x is 6x, and then minus 12. Eliminate the denominators, and we're left with 4 minus 2x over 6x minus 12. Now that's our simple fraction, so we need to reduce. The first step in reducing, of course, is always factor. Okay, so we factor each part. GCF for this guy, 2 goes into both 4 and 2, so we're left with 2 minus x. And what goes into these? So 6, duh. 6 goes into both this 6 and 12, so we're left with x minus 2. So you can reduce the numbers. 2 goes into 2 once, 2 goes into 6 3 times. This is 2 minus x, and that's x minus 2, and we discussed that before. They're off by a factor of -1, so you may cross them out and multiply by -1. Multiply leftovers, so 1 times -1 is -1, and 3 is down here. So this one is -1/3. So this mess up here is really just -1/3. Crazy. All right, let's do one a little bit more involved, where the denominators aren't exactly the same. Here we have a 3, and we have an x. So, easiest route to take when finding your common denominator is just multiply them together. Now, we discussed how to find a common denominator, and you can follow those steps, but here, really, 3x. There it is. 3x is a good common denominator. So we need to get them all 4 fractions to have 3x as a denominator. So this one needs both the 3 and the x. You want to remember, whatever you do to the top, you got to do to the bottom. This one over here just needs the x. It already has a 3 down here. So you multiply it times just x. This one needs both 3 and x. And this one has the x, but needs the 3. Okay, make each part. Okay, this is the top part right up here. So we have to multiply this together. Please remember your multiplying rules. 3x is on the bottom. This is 3x, that's 3x, so we can just put one of them. 3x squared, when we multiply that together. And -1 times x is -1 x. Okay, so we work out down here. This is 3x. Okay, whole denominator, this is all 3x. And then this, -3 times 3, is -9. Great. Now we reduce. The 3x's are the same, so those can cancel out. We put this one on top, this one on the bottom. We have to factor each now. This is our simple fraction that we need to reduce. So, factor out the GCF. Alrighty, I had to switch cameras because mine keeps turning off. So I believe we factored here, factored the top, and got that. Factored the bottom, got that. Nothing was common, there's nothing to cross out. Even though we want to, we can't. So that's it. That's the answer. We're going to do one more. A fun and exciting problem for you. This one's a big one. It's got everything you could ever possibly want. Alrighty. So we have this problem. Switch colors for fun. This one, everything is already a fraction. We're going to keep change right here. And that one's positive, so no changing necessary. Now, to find a common denominator, you could multiply them all together and get like a cubed b cubed, that would be big. You may recognize that a squared b squared would be plenty. Would be a fine common denominator. So we've discussed common denominators before. If you need help with that, different story. So our common denominator that we're going to choose is a squared b squared. So we have to get each one of these little fractions to have a squared b squared as their common denominator. So this one already has the a squared, just needs the b squared. This one already has the b squared, just needs the a squared. This one has a b, so it needs a little extra. It has one of the b's, but it needs one more. So it needs an a squared and a b. Makes it look weird, but whatever. That's the way it is. This one already has one of these a's. It needs one of the other a's and all of the b squareds. So in the end, a squared b squared is on the bottom of this one. What's on the top, we multiply these two together, we get b squared. These two together, we get minus a squared. On the bottom here, bottom again is a squared b squared. Top for this one, we're just multiplying by 1, so it's just a squared b. And this one here, just ab squared. So this is a nasty problem. There's no doubt about it. But we'll make it slightly simpler since these are exactly the same. They just go right away. And we're left with on the top is just this, and on the bottom is just this. So b squared minus a squared on the top, and a squared b plus ab squared. Now we have to factor. All right, so here we have b squared minus a squared. We can factor that. That's dots. B plus a, b minus a. And then on the bottom, it's positive, so there's no way it's dots. So this has a, you got to see what they have in common. This one has an a and a b. So GCF would be AB. If I divide this by AB, I'm just left with A. Divide this by AB, I'm just left with B. So these are exactly the same. The reverse addition. And we're just left with B minus A over AB. And this